your first time of seeing my video, you need to hit the subscribe button, turn on your notification bell, click the like button at the end of this video, and comment in the comment section below because I love to hear what you have to say. Hello beautiful people, it's Mercy from Hope Alive, and thank you for clicking on this video because today I'll be discussing extensively the role of vitamin A in eyesight part 1. So stick around and watch this video to the end because it is really amazing. Okay, so in this video I would also be showing you what the beta carotene structure looks like and probably how to draw the beta carotene structure. And to do this, actually I'll be using the app called King Draw. I actually downloaded this app when I wanted to do this tutorial, and I found it as a very amazing app when it comes to drawing chemical structures. I actually drew this. This is an example. This is the beta carotene structure. I drew it with the app. Yes. So the beta carotene structure, as I had earlier said, contains two beta ionic ring, and I would be showing you where which of them is beta ionic ring. So this is, I'll be clicking on my drawing tool. Okay. So this is the beta ionic ring, actually that one there. Okay, the only problem is this app does not have a function for drawing circles, so I'll just show you quickly. This benzene like structure here, this structure that looks like benzene, this very one here, yes, this one, it is our beta ionic ring. This one here. Okay, I'm just going to label the, okay, I'm going to label the structure now. So this structure here is very one. Yes, this very one is the beta ionic ring. That is our, I just click text now, and I'm going to label it as our beta ionic ring. Oh, ring. Okay, then I'm going to move it here. So this is our beta ionic ring, and according to our earlier conversation, you can see that the beta ionic ring here also has, the beta ionic ring here is just inverted on this side. It is the same thing, just like it was turned upside down. So this is the second beta ionic ring, which makes the two beta ionic rings that the beta carotene structure has. Then in between this bond, this series of carbon chain bonds, are the polyprenoid chains that I had earlier said. So these are the polyprenoid chains. They are 20 in number. Actually, that's the way I actually use to get the numbering correct, and make sure to number them according to the starting point here. I number them from the starting point here. I number this as my number 1. You can actually get this. You can actually get this app. I think it is very relieving. cancel. Okay, you, I'll be using you for this. So this is where the number one, this is where what I count as my number one, and then my number two would be here. Okay, that's a little bit, yeah. This is where my second carbon chain is. If you've been conversant with the chemistry, with biochemistry as a whole, and you've done your fatty acid, you would actually recognize this kind of chains. It appears all the time when you study your fatty acid. If you need me to discuss fat and fatty acid topic in biochemistry, just tell me in the comment section below, and I'll make sure to do that extensively. So this is our carbon number 1 up to number 20. Our number 20 ends here at this tip. So you can count it yourself and you will see that there are actually 20 of them. So this structure is actually a skeleton of the beta carotene structure. The beta carotene structure is actually has the carbon chain appearing in the midst of these joints here. These joints, like the one where I wrote number 2, they're actually carbon chains that should actually appear there. But this skeleton is majorly used, and it is not a problem. You can actually use this to draw your beta carotene. It makes it easier.
It will be more like this when the carbon chain are present.
But that is the real structure, if you care for the real structure. So at this part where I label the site of cleavage, it is the point where the beta carotene structure breaks into two. And I had earlier told you that the beta carotene structure is theoretically divided, and when divided can theoretically produce 2 vitamin A. Yeah, so at that point where it produces 2 vitamin A, this site is where it breaks down. Actually, I think this site is our number 10. I think we have to number it all so we could know for sure. Yeah, I think it is our number 10. I think it's our number 10. I'm going to show you now. See, this is our number 3. Then our number 4 is going to be here. Number 5 is going to be here. Our number 6 is going to be here. No, okay, I'm just going to bring it back to where it should originally be. That's our number 6. Then our number 7 is going to be here. Then our number 8 is going to be here. One, two, three, 4, 5, 6, 7, 8, 9. Okay, it's becoming clearer. I am so glad you're understanding this, because I just have to believe you're understanding this, because I think I'm giving it to you in the simplest way possible, and I really hope you're understanding this, because it is very important for you to understand how the beta carotene divides, so you could better understand where vitamin A retinoids come from, how they come to be, and then understand how it functions in eyesight. So these are 13. I had earlier told you that I actually count it. to just ease my stress, I actually count it to, where did we stop exactly? I actually count it to, okay, actually counts it to, actually counts it to 20, so I will not have to stress myself. So whenever I want to draw a beta carotene structure, all I need to just do is know the features that my two unknown, remember the features that my two unknown has, my two beta unknown rings, the structure it has, and the qualities in those structure, the qualities that make it different. And then I think I'll probably just draw. Okay, I think, okay, we are almost done, and this is our 19. I think I'll just, okay, then I'll arrange it. So this is our 20 here, carbon 20, this is our 19. So here you go. Oh, let's undo that quickly. Okay, here you go. So these are the carbons 1 to 20, as I had earlier told you. So when you want to draw this structure, all you have to put in mind is, okay, I have to know what my beta unknown ring looks like. It is actually a benzene ring, similar to this one. It's actually a benzene ring. All you have to do is draw a benzene ring first. You probably learned that in your chemistry. Then you have to remove, you have to make sure your benzene ring does not contain the qualities of a benzene, which includes the 3 double bonds. Because as you can see, this ring, the beta unknown ring, has just 1 double bond, and that is here by the side. Sorry about that. That is here by the side. So then you have to know that this point, your bond actually crosses at this point. So it actually crosses at this point. There are actually 2 additional lines it makes. I'm going to show you how I successfully drew this with. Would you look at that? When you're drawing it on your probably test paper or something, I think it should be easier. It certainly would be easier. Okay, this was not what I was expecting to draw. Okay, looks like someone's got the gist. Yeah, you see that? Okay, this is more like a different type of benzene. Then you have to remember to install your methyl. You have to install your methyl. You cannot forget that, because that is like the only important thing that you have to maintain in this structure, and you have to have it there. Yes, so when it is there and it is intact, then you can begin to draw your polyprenite chain, which is just a series of zigzag, 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 zigzag. That was not what was intended. You can only draw it, bring it close, give you something like this. Okay, yeah. So zigzag, zigzag, then while you draw it, then you have to do the counting in your mind or heart or wherever you best do your counting. So I think I've drawn 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 15 okay, 16 17 18 19. Okay, I think there should be 20 already. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19. Okay, this should be our last 20. Then when you're done drawing all 20 of your polypenoid chain, then you have to realize that the 20th of your polypenoid chain attaches to a new benzene structure, a new beta ion ring. I would stop calling it benzene structure now, but I actually call it benzene structure so you can understand, you since you're very familiar with the benzene structure, I suppose, so you can understand the point of view that we're coming from, and it can be easier for you to draw the structure, So here is the beta ion structure. I just deleted all the features of benzene that it actually possesses. So the 20th carbon, actually the 19th carbon, attaches to this carbon on the beta ion structure, therefore making it the 20th carbon. So it is actually a distorted form. It's just inverse form. So this part was turned upside down. So that is what you're just going to do. So since it is turned upside down, this line is going to be down here. It's going to be down here. Okay. It's going to be down here. Yes. And this will be down here too. Oh, sorry about that. This will be down in here. Okay. It is not strict again, but with much practice, that is if you decide to pick up this app. I got it on Google Play Store. You can actually get it yourself if you think it is worthy of your use. You can actually get it. So now I have my 2 beta ion structure here, and my beta carotene structure is almost done, then except for the fact that the polyphenol chain has a double bond on this side, on the second, on this side, you can see it all has a double bond. It has a double bond on this side, so you must always remember the double bond. Another thing you must always remember in the polyphenol chain is it has a methyl group attached to the carbon. So, and this occurs at strategic points. The methyl attached to the carbon at the carbon 4, the carbon 8, the carbon 13, and the carbon 17. And I'll give you an easier route of knowing where your methyl group should attach. So, but before that actually, I would like to input my double bond now. Okay, I like to input my double bond now. So that is what I'm doing. I'm putting my double bond. So when you see it, you will realize that this structure is actually easy to know by heart. I don't think you should have any problems knowing the structure by heart. in an exam, and I think with my little explanation you should be able to get and to know. You should be able to get and to know this structure now, because I think I just made it easier. So I'm done drawing my double bond. So I'm done adding my double bond. So now I'm going to impute my methyl group. So this is how I impute the methyl group to make it easier for me. I count from this bond. I count 1 to 2 to 4 from the beginning. 3, then carbon 4. So I count carbon 1 to 4, and then I canceling this, and then I apply my methyl group. Did you get that? So if you notice that the moment I added my methyl group to carbon 4, the double bond goes upward, which shows that while drawing your polyphenol chain, you must always remember that the double bond at the point where the methyl group attaches changes position. It does not stay down, it stays up as a result of chemical laws. You get that? So I then begin. After I counted 1 to 4, then I begin another 1 to 4 count, which is 1, 2, 3, then 4. Now, then I add the second methyl group. Oh, sorry about that. Let's add my second methyl group. So when you see this, it shows me, it makes me understand that when starting from the beginning, when starting from the beta unknown ring, I just have to count 1 to 4, then add my methyl group, then count another 1 to 4 after the methyl group I added, then add the second methyl group. Then after that, I go to the next beta unknown ring, then I begin to count my 1 to 4 backwards. Okay, there was something going wrong. That's my number 2. Okay, someone's got a mind of his own. Number 3. Okay, now each one of them is probably doing what like. Okay, so then now I'm counting my then number 4. Then when I get to the 4th, I just give another branch. Just give a branch to my 4th carbon starting from the back, and I apply my methyl group. You just watch this. Then I begin my counting again as I had earlier done in the first one. So this is number 1, number 2, number 3, and number 4. That gives me my 4th carbon. So yeah, so then I add my methyl group to it. Yes, so I add my methyl group to it. So the first methyl groups are, if you watch now, it is exactly the same as the one I had already drawn. You see? So this makes it easier for you to actually know where your methyl group should be, where the right positioning of your methyl group. Then if you also noticed, something else you need to notice is the methyl group, when the carbon 17 branches downwards, there is no change in position of the double bond that precedes it. You notice that? You notice that too, right? So that is probably because of the law. So assuming there was a methyl, assuming there was a double bond after this methyl group, probably it would probably have changed position. But I am not a chemistry student. I am just giving you a simplified method and the best way of how I got to draw the structure and understood it, and it became easier for me to input it in any exam. So now, to know my site of cleavage without cramming this, I just know that when I'm done drawing my methyl group, adding my methyl group number 8, adding my methyl group to the to the carbon number 8, I just have to count 1 2 1 2. So 2, which makes it 10. I had earlier told you that our number 10 is present in is where the side of cleavage occurs. So that is all I just have to do, since I now know where my number 10 is. And this methyl group makes it easier. I just counted. So you also have to realize, then I'm going to apply. Same thing when you're counting backwards. When you add your second methyl group, you just have to do 1 2. Then notice that the site of cleavage is not the carbon chain. It is not the carbon on the chain. It is more of the it is more of the it occurs majorly on the double bond. That's the point of the double bond. That is where the splitting occurs. And so you must always remember to add that in your labeling the side of cleavage wrong. That could be very problematic for you in your exams. So you have to know the right points of cleavage. So I hope you really understood the beta carotene structure, and I hope I really explained it well. I hope you understood this perfectly. And if you think you need to try this, you can just easily get this app. The name of the app and how to get it will be in the description box below, so you can just click the link to get this app on your Play Store. Wow, welcome back. So I hope you enjoyed that section, and I hope it was a very educative one for you. I also hope you actually learned one or two things. So for the apps I used, I'll be putting it down in the comment section below. You can get one for yourself to do more tutorials, and also consider clicking the like button and subscribing to my channel to enjoy more of these highly educative videos. And I also would love to see you once again and hear your comments concerning this video in the comment section below. Once again, I'm Mercy from Hope Alive, and I'll see you in the next video. Bye.